Hi everyone, welcome to Differential Calculus. Today we explore lesson 4.7, Optimization, Part 3. Example 1, how to cut out a rectangle with the largest area from a semicircle of radius r. Sketch out the semicircle. From here to here, it's r. We can take this as the angle theta. So on one side, we have r sine angle theta. On the other side, or cosine of the angle theta. That is from trigonometry, because if you look at the right triangle right here, it's the angle theta, y, x, then we know that sine of the angle theta is using the fact that the radius is r. Opposite over hypotenuse. Opposite is y, hypotenuse r. So it tells us that y is r sine theta. Yay! Pretty cool. Huh? So with this information, we can sketch out a sample rectangle. This is what a sample rectangle look like. The question asked us for the largest area. So we have to maximize the area function. Area is the function in terms of the angle theta. And that is length times width. The length is 2r cosine theta. The width is r sine theta. R squared times 2 sine theta cosine theta. And that would be r squared sine 2 theta. We know sine 2 theta is between -1 and 1. So we will achieve the maximum area when sine 2 theta equal 1. Sine of pi over 2 equal 1. So 2 theta equal pi over 2. And theta is equal to pi over 4. Now we can figure out the width and the length. Width is r sine theta, which is r sine of pi over 4. And that is r times root 2 of 2 r. Root 2 of 2r. The length is 2r cosine theta, which is 2r cosine pi over 4. 2r times root 2 over 2 root 2r. Example 2. An 8-foot tall fence runs parallel to the side of a building 4 feet away. Find the length of the shortest ladder that clears the fence and reaches the building. Problem is pretty short and sweet. Let's just draw this out. Here come the building. Here come the fence. And the distance is 4. So now we want to get a ladder that would clear the fence and reach the building. So this distance right here is x. The ladder, I'm going to have the distance here to be L. And as for the building, the height from the top of the ladder to the bottom of the building is Y. We have two right triangles. We want to minimize L equal to square root of Y square plus X plus 4 square. That is the L from the Pythagorean theorem. L is a function in terms of two variables. We need to reduce it to a function in terms of one variable. And to do that, we will use similar triangle. Ratio of the two sides of the bigger triangle, Y over 4 plus X is the same as the ratio of the smaller triangle, A over X. So Y is A over X times 4 plus X. Which is 32 over X plus A so Y square is 32 over X plus A square. And now we can do the substitution in here. L is root of 32 over X plus A square plus X plus 4 square. It is not a good idea to find the derivative of L because the critical number of L is the same as the critical number of L square. If L is equal to root of fx, then L prime is 1 over 2 root of fx times f prime x. And when we set it equal to 0, right? F prime x equal to 0. Critical number of L square is L square equal to root of fx square, which is fx, right? So the derivative of L square is f prime x, and we set it equal to 0. So what happened here is that critical number of L and L square are the same. Mean that instead of working with L, we're gonna work with L square. L square is 32 over x plus A square plus x plus 4 square. Derivative of L square is 2 times 32 over x plus A multiplied to the derivative of the inner function minus 32 over x square plus 2 times x plus 4 times 1 derivative of the inner function. From here, we have 64 over x plus 10 multiplied to negative 32 over x squared plus 2x plus 8 let's distribute negative 32 over x squared. So I have a negative 2048 over x to the 3 minus 512 over x squared plus 2x plus 8. And we're going to set it equal to 0 to solve for x. Let's multiply both sides by x to the 3. To get rid of the denominator, 0 is negative 2048 minus 512x plus 2x to the 4 plus 8x to the power 3. Yay. And from here, we can factor out the 2 x to the 4 plus 4x to the 3 minus 256x minus 1024. And we can factor this further using the rational zero theorem. And it will factor out to be x plus 4 x to the 3 minus 256. So x plus 4 cannot equal to 0, and 17 for 2, because x is distant. Distant cannot be negative, so the only thing that can be equal to 0 here is 0 x to the 3 minus 256. So x would be 256 to the power 1 over 3. Well, we have one critical number, and based on what we have learned in the previous section, this is the local minimum. So that is the absolute minimum. Right? You can work out this problem, do the first derivative test, and then you see that this number is the local minimum. So once we have x, right, we have to figure out the length of the ladder. And as we can see, the length of the ladder, just do the substitution in there and simplify it. So now L is root of 32 over 256 to the power 1 over 3 plus 8 square plus 256 to the power 1 over 3 plus 4 square. And this is the length of the shortest ladder. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.